Hi, it's my pleasure to welcome Ayelet Shavit from Tel Hai College, who will be speaking to us about scientific replication and academic outreach. Can it work together? Please.
So I know it's late, and I have a very soothing voice, and so if it gets and I forgot my notes, so I'm hoping to be articulate enough to get only 3 main points, which are first I want to thank the people involved in this research. There are many people involved in this research. I thank them dearly. I believe in a philosophy of science that's involved with scientists. And when I try to do philosophy of science with local people, I'm involved with the local environment. So I can't talk about each one separately. These are amazing people. The only reason I can talk about what scientists do is because they talk about what they do. And they do it so articulately and so clearly that I just have to offer the stage for them to kind of reflect on what they're doing. And I think there's a lot of philosophy going into the routine, technical, day-to-day work. And this is what I'll talk with you about mostly. Now, only 3 main things I hope to show. First, to explicate some of the practical meanings of replication. And I will do it in ecology, mostly in biodiversity research. And I will try to show some of the underlying practices and epistemic ideals, the things that make us do a certain thing in a certain way and evaluate that thing as the best we can. I'll point to a problem that emerges from the diversity of meanings of replication. And in biology, the data is so diverse, the scales are diverse, and they change. And so dealing with doing the same thing again is especially difficult in biology and in ecology that is built upon dynamic interaction. It's even worse, okay? So there's no point in criticizing or in looking critically on someone you think who has done not such a good job. I went to the people I appreciate the most, I think, who have done an amazing job. And I think only there, critical thinking, not only there, but especially there, critical thinking can make some difference. It's not interesting to criticize someone who's not really good at what he's doing. So this is the meaning of my critical thinking, okay? And I don't try to disrespect anyone. And at the end, I will try to argue that given that issue with replication, a proactive approach to local knowledge can be and sometimes is a recommended path to help resolve some aspects of the problem of replication. And I don't think there is a general solution to the problem. But sometimes there are local resolutions. And when you think about replication, local knowledge doesn't seem to fit in. We want general results, okay? We talked a lot today about standards. So how does local knowledge fit in? And I'll try to convince you. I don't know if it will work, but this is what I'll try to do. Okay, so some of you thought replication might not be very important. Aaron Allison and I thought it is. So we invited biologists from different disciplines dealing with different questions to think about this together. And I think the most compelling citation I can say of why replication is important was not said by me. And Chafin and Schaefer say that replication is the set of technologies which transforms what counts as belief into what counts as knowledge. And this talk will not be about fraud. about a problem of pseudoscience, about how to trick people. The problem of replication that I will address here is the problem that every scientist who wants to do the best he or she can must face. Okay? These gaps. And the types of replication that I will talk about are based on, first of all, a paper I wrote. I read a while ago, a historical paper. Okay, she's not here. So in any case, it was really valuable to me to see that the different concepts related to replication, and ecologists often talk and work with computer engineers or computer science people for taking the ecological data and putting it into large databases. So they need to think about replication also in the context of the data that is not directly connected to the empirical data, but they need to think about replication of records. And so what was very useful was the understanding that replication is this generic term, but it could be better understood as two different things. One is repeatability of the same measurement. I call this like you focus on the process, okay? And it could be a calibration process. You want to check your machine if it's working well. It can be a resampling. It can be doing the experiment again. It could be you run your model again. And that model could be just an occupancy model, just to check your data, if your data is okay. And it can be an analysis at the next level. So there's many points in the working stage where you need to do this, you need to repeat the process. That's one meaning of replication. And what you want there is not identical. You're not looking for identical results. You're looking for comparable results. You're looking for you need it to fall within a certain narrow variance. But it doesn't have to be identical. When it needs to be identical is when the ecologist meets the computer person. And then what you want is reproducibility of the same result. And for it to fit, often you want identical results, not always. But what is more important is that it's not necessary for reproducibility to repeat the empirical process, okay? You're focused on the result. And often the talks we had here today combined the two. They talked about repeating the process and getting a reproducible result. Some of the work has to do only with reproducing the same result. Sometimes it's both, and sometimes it's just about the process. You don't have to link them all the time together. And that separation could be helpful when we try to describe what scientists actually do. Now, when you replicate something, why do you do it for? There's so much energy going and there's so much time consuming. Why do it? You do it because you hold a certain epistemic ideal of doing the best I can. So what does that mean? There's two reasons why to replicate something. First, you want your results to be accurate. And accuracy can mean you want to answer a question, so did my experiment refer to a certain causal process that's out there? Or did my experiment just like we heard so beautifully a while ago, maybe my experiment and the analysis I did of my experiment just caught onto a random set of events. So what actually happened out there? And I want to do it again and again to make sure that my results are accurate. But sometimes, and in that case, when I'm doing a resurvey or another experiment, p-value really matters, right? I have this null hypothesis that the experiment is random, the results are random, and if I get a result that's significantly different than my null hypothesis, I think maybe I caught something that's maybe what I described here. I described a causal process. But it doesn't have to be that way. Often when we talk about accuracy, when we want real results, it's not about p-value, it's about the fit to the empirical data. And then, of course, sometimes p-value relates to the fit, as you just showed, but it's not necessary, okay? So sometimes I'm asking, does the model prediction fit the empirical data with enough precision? Now, precision and accuracy, of course, it's not the same thing, right? I can have my weight. How do you call that machine? The weight that you check your weight? How do you call it? Scale. Okay. So, sorry. I told you. So I can check myself again and again on my scale at home, which I don't have, but I can do that. Buy one and check it again and again and again and have a very precise result. But it will be biased by, 10 kilos. So my scale will be very precise but inaccurate. When you're talking about realism in your model, often you would use, sometimes, not often, I don't know if it's often or not, sometimes you would need both, okay? You need to talk about your results as fitting the empirical data with enough precision. But that's not the only reason we replicate. So sometimes we want our results to be real about a particular place, a particular population. I really care about that nature reserve next to my home. I really want to capture which species are there. And I want my conservation plan to fit exactly what's there. But sometimes what I want and why I replicate has to not about the accuracy of my description of this population, but what I want is general results. What I want is to extrapolate from what I found here to other populations. So in this case, the questions I'm asking are very different. I'm asking, are the results measured in a given population or a given context? Whether or not these results are causal or random, that's not the case here. But are the results found here, are they representative of other populations, of other contexts, and maybe universally representatives, okay? Now, I don't see you wouldn't think there has to be some clash between those two. You can have both. Why not have both? Okay? The problem happens when you go out to the field and when you see what people actually do, or their PhD students. I picked the ones who went together to the field with their PhD students. They didn't just send them. So what we have is, okay, so I'll say it this way. You would expect to do a good enough survey or experiment when you can both get realism and your results will be real and general. And it's what I'm trying to show you here is the specific context where the choice that you make is exceptionally hard. I'm trying to flash out a philosophical problem with replication because we all know there's a technical problem. That's not interesting philosophically. Is it hard? Of course it is. Sometimes we don't have the money? Sure. Sometimes people are sloppy? Sure. And everyone does the best they can, let's assume. Okay? What? Which one? Probably a spelling mistake. What? It's a spelling mistake. Yeah. No, it's not in Hebrew. Okay. How do you say metrics? M-A. Sorry? Usually the speller shows me. Okay. So, So the issue is this. I'm not talking about a practical issue. And the problem emerges when we have different ideals of what does it mean to do the best I can, okay? Then it becomes philosophically interesting, okay? So let's say we go to the best people in the field. I went to the best ones I knew and who agreed to have some philosopher tag along, okay? That's also, not everyone wants that. So let's assume I go to the best people, and they wrote the grant together. They worked for a year on the project together. They got the money, okay? And they appreciate each other for years. They worked together for years. I went to the MVZ at Berkeley, Harvard Forest in Harvard, and a group in Israel called the Maharad. 3 groups, okay? They know each other, they appreciate each other. Everything's great, they got lots of money. Now they go out to the field. Now what you can see, there are different stages of the work, okay? We talked a lot about this, so I won't talk about it at all. Maybe if I have time, but probably not. And I would like to follow the different stages of the work, given that you have different motivations for doing the work, okay? So you want to be universal, you want generality. Often people would suggest have a common standard. You wanted to build a database for your data, and it's taken from various areas. The first thing to do, to think of, is let's have a common language and a common standard, okay? How do we do it in the field? We'll have a grid, longitude and latitude, okay? And it will be very rigid, and it will help us that way. Another thing is if you're not, another thing is what I really want is I care about representativity, and I care about generality, but mostly I want an accurate description of where I am. So you put a team of biologists, and one of them was he's a zoologist, keen zoologist. When he goes to the field, he wants the model that will come out to accurately describe what's out there. The other one is a theoretical ecologist. Mostly what he wants is to test a hypothesis. And the database is a tool for that. And the grid is a tool for that, okay? And another guy, I'm telling you, interdisciplinary work is it increases your chances to get the grant. So there's a team. And the computer person, what he really wants is things to be, to have a common standard. And now they wrote the methodology chapter together, okay? And they go out. And I've seen it again and again and again. The only difference was the tone. Israelis tend to be louder, okay? But the scene was very, very similar. You go out and you want to do a resurvey. So this guy was here before you, and you want to see if changes in climate change, if changes of temperature did some kind of change in species distribution, if change of land use has made something of species distribution, and you care to find a causal connection, okay? So how will you do the field work? They all decide together, okay, we'll compromise, we'll have a grid, okay? Every 20 meters, we'll put a trap, and they all agree, okay? And then they start walking, and they reach a point after 20 meters. Now, they all read, they're excellent scientists, so they read and they know that this guy that was here 50 years ago found voles, okay? And the zoologist knows how voles behave. So when they reach the 20 meters, he sees right next to them a little trail, grassy root, and he sees a little trail, and he knows that voles, they walk on these trails. In Israel, it will be a different species. It's the same phenomena. So they reach the point, and he sees the trail, and he takes the trap, and he says, okay, we should put it here. And the theoretical ecologist said, what are you doing? You can't do that. That's backward reasoning. You can't put the trap where you think you will find something. You have to put it randomly. And if you find something, nice. If you don't find, too bad. Okay? And the computer person, well, he wasn't out in the field. So, okay, so you have a grid. They all agreed. Now, the better you are, the more precise you are, the worse the problem. Because they stand there. And one says, this is just biologically meaningless. If I put my trap randomly and it's on a rock, and I know there are voles here, I will not find voles. What does that mean? He says to him, you know what, I can take this and I can put it in a parking lot right next to here. It's just the same. It's biologically meaningless. The theoretical ecologist says, look, I understand, but there's no other way to do this. We're not, so everyone has a different motivation or a different ideal of what is to do things the best way. And it's unsolvable. Unsolvable. In the US, it was decided, the high-ranking person simply, everyone were very polite, and they were smiling in California, a lot of smiles. 5 minutes and 10 minutes, and the one who was high-ranking decided what will happen. In Israel, they started arguing very loudly. Eventually, the technician said to the one high-ranking, you know what, you do what you want. I'm not doing this because I think it's wrong. And he just went, okay? But a decision was made, okay? And it had to be made. Now, there was and later on, they became all friends together. When the data arrived, so eventually they had to make a decision, okay? It's the most basic opening start to 50 years of survey they're planning now. They had to make a decision. And now they could be all friendly because each one has a different set of what is his minimum unit of analysis. So when you have all this raw data coming in, you have to do some synthesis, some work on your data in order that it will be meaningful for your analysis later on, okay? And so for these two guys, for the computer person, it was very simple. You just take the smallest unit that you have an average with. It happened very easily because what they did is taking the average of these 40 traps. The theoretical ecologist was happy because it answered his question. And the zoologist was happy because initially he won, and the trap was put where he thought, okay? And they could do something with the data and put it in their database. Now, a lot of philosophers of science hear about incommensurability and indeterminism. And all these philosophical concepts, they're kind of conflated in everyday talk. And we heard about paradigm shift today, and people use Kuhn's terms in a way that's conflating them. So people would say incommensurability as if I mean no fact of the matter. But it's completely not the same thing. This is incommensurability in the sense that there is an empirical difference. The trap could be here or here. And it's not that you could even say that one guy was wrong or correct. There is no way to make a decision, but whatever decision you make makes an empirical difference. And so when I interviewed these people later on, they kept saying the same thing. They said, you know, I don't understand him. He's such a smart and intelligent person. How could he not see that this is just, you can't do it? They kept saying, I just don't understand him. I just don't understand. Because that's what incommensurability is about. It's not about truth or false, but it is about an empirical gap. Whereas here there is no fact of the matter. This is indeterminism. because there is no empirical difference. They took the average from all of them. And they managed to agree on 40 traps. It doesn't really matter where the 40 traps came from. So they could work with this, okay? And later on, well, no, I don't have time. But working with ecologists can deepen and improve your philosophical understanding, and the other way around, okay? So for an ecologist, trying to explicate what he's doing to a philosopher can improve, I don't know if improve, that's pretty too much to say, but may help him do his job, okay? So that was the first stage. Then they could reach an agreement on the data synthesis. And the whole problem emerged again when they had to take the data, very simply, and just put it in the database. It's just technical. But it was a huge issue. Sabina Laioleni talks about this in this beautiful book she wrote in 2016. I recommend it to everyone. And there is a problem here. It is very different. If you want a common standard, you want one metadata. Metadata is data about data, so information that describes the information. It's the categories in your database. And you want just one, with one interface, so that everyone can do things the same way. But here, he would say, the zoologist would say, this is ridiculous. If you tell me, the metadata we want for a trap is the place and the time. And you choose place as longitude and latitude. And you choose time as a certain date or hour. But from an animal point of view, if I came back on the same date, it doesn't mean I came back on the same time. Think about a migrating bird. Okay, where I live, it's right on the sources of the Jordan River, and we have 500 million birds migrating right next to us. You know, the Jordan is a nice little line. It's helpful. And they land. And so when you think about time, from this perspective, when you want an accurate description of how the animal experiences its environment, time is not about the date. Because time has to do, yes, with the date in the sense of time of stars, but time also has to do with my internal hormonal cycle, which also gives me a cue when is the time to migrate. And if you're a crane or some other social bird, the same time is also the time that my colleagues fly. If I stay here, time is a social thing. So time is social, and it's hormonal, and it's exogenous. It depends on the stars. Same thing, I don't have time, with space. Longitude and latitude don't tell you if you came back to the same place. Okay? The most simple thing in your metadata. Okay? Location, time. It's not simple at all. It depends what is the purpose of what you are doing. Okay? So it's a whole issue now. And when they decide upon a single metadata, what the zoologist finds himself doing is building his own little data for himself, for what he values. It's a huge project. So here, in this stage, the guy who calls the shot is the computer guy. So what he wants is interoperability. He wants the next time these guys will want to retrieve a specimen from the field or ask a question about a disease, that it will be automatic, the answer. But for that, you need a single metadata. And for the zoologist, he can't work that way. He prefers this. And what he does, he caves in, but he keeps on the side the data that he thinks really matters. And then interoperability always fails. And they keep complaining 3 years in Berkeley, and 5 years in Israel, they keep complaining all the time. They think the problem is with the computer people. No, it's a much deeper problem. It's not a technical, it's not just a technical issue, okay? So you have that, and I don't have time to go over all of it, but what you see is that at every stage of your work, it really matters if you're going mostly for generality, mostly for realism, okay? And you will make different choices. Okay, thanks. Yeah, I should really move forward. Yeah, I should. Okay. What's the problem? The problem is that it's fundamental. Replication is fundamental for doing good science, okay? But scientific methods and goals and ideals vary, and they often clash. Hence, one can only repeat a research process and reproduce its results the best one can. But if different understandings of replication assume different ideals and practices, then the best one can do, okay, if everyone thinks about it differently and they don't discuss it amongst themselves, then trying to repeat or to reproduce the same thing on the same scale inevitably reaches inconsistencies. Some of them are empirical when it's incommensurable. Some of them are semantic when it's indeterminate or underdeterminate, which is another thing I didn't talk about today. But it's inevitable. Okay, so what? Maybe philosophers can say it's inevitable and end the talk, but for ecologists, it doesn't work that way. We need to do something. So what? Here, philosophers could be relevant to philosophers, to ecologists, to scientists, because if you unfold the different meanings and practices for replication, and if you do that for the different goals and stages of the work, then, and you explicate where people agree and where they disagree, you can coordinate your work and you can choose more intelligently and more transparently between the areas where it's most relevant to find a common standard and the areas and types of questions and types of research where what you really want is to alternate between different standards. Maybe you alternate upon scale, like what I showed you here. On the smallest scale, they went with accuracy, or with this kind of internal understanding of the animal from within. On a higher scale, they went for generality, okay, and for an exogenous type of description. So you can either alternate between standard, or you can decide for a common one. And the main, so this is one resolution that I found, that when a scientific project is successful, this is actually what they do. They start talking amongst themselves. Okay, so what do you mean by replication? Okay, so what do you mean by doing the same thing again? They do this kind of dialogue, critical dialogue between themselves, okay? Now, if, let's say, you value mostly accuracy, and you want your model, and you have a question that you really care about its relevance to the empirical world in a specific context. Let's say that's what you want. And the people I followed cared about conservation of particular places, okay? Let's say this is what you want. In this case, what can be very relevant to you is local knowledge. And people would say it, but it's so difficult to reach local knowledge. It's time-consuming. And if you only want generalized results, you need not bother. Being local is not like being local in a place is not like being a resident of the place. Being local means I belong here in the sense that someone else does not. So the concept, the understanding of difference is embedded in being local, okay? So it's especially difficult to enter that into my general schema. And scientists often want general schema as well. So if I want only generalization, don't bother. For a good reason, don't bother. If I am replicating an experiment or survey, or I run this model, whatever, for accuracy prediction, then adding local knowledge can add crucial causal explanations or data, and thus may improve my replication. But it's so difficult to get to these people. In biodiversity hotspots, you often find people who are underprivileged. That's one of the reasons that area is not urban by now. It's not ruined, okay? And what I want to give you an example is of one work we did. Now my aim is different. I want to try and seduce you. Those of you who aim, scientists or philosophers who aim for explanations and descriptions that would be accurate, I want to seduce you to work with local population, with people outside these walls. And I want to give you one example where I think it worked. And stupidly try to invite you to try it as well. I mean, I'll have an argument for it, but so this is the goal. And I want to tell you about this example. It's called Town Square Academia. It's a project that began where I live. I live in Israel in the northern tip, right next to the Jordan River, a mile from Lebanon, not in the occupied territories. And where I live, it's an extremely peripheral area. It's the most peripheral area in Israel. And in 2011, we had the social protest, social justice movement was very strong. And half my students were in the streets building tents and sleeping in tents. And a lot of local residents came to the tents. And me and my colleagues went down there. And evening after evening, we had all these talks. And we found out that people who live a kilometer away from the college have never been there. And they would never dare go there. Okay? But when we talked about a lot of issues, they had a lot of information to add. Okay? And then we remembered, it was a semester that I had to replace a teacher that teaches Greek philosophy. And then we remembered another guy who taught outside campus. And when you think about Socrates walking in the agora, in the Athenian town square, okay, he needs others to learn from them. There's no tuition. And we established this project called Town Square Academia. And what happens in that project is that, why nothing happens when I'm clicking this? That's not good?
Use a different finger.
Okay, so first of all, we have the courses. We have about 10 courses per year. There's hundreds of people coming. Each course, the courses are free. It costs us $5 to attend the course, okay? And they're in various localities, in hummus joints, in elementary high schools, on the riverbed. They're all over, and the locality of the course depends on the type of question that the local people raise, something that is of interest to them, okay? And it's built upon voluntary expert lecturers. So this is not about some benevolent academics going to these poor, ignorant civilians. No, it's about finding a local expert who is willing to volunteer to work together with an academic expert, build a syllabus, and teach together. Okay? It's about people volunteering to host the course. And it's about diversity of places, of learners. And typically, we use academia, knowledge, and science as a tool for getting people to meet together who they never meet. In Israel, for hundreds of years, you have Arab villages here, you have Druze villages there, you have Jews here. It's over, I don't know how many, hundreds of years it's like that. They hardly meet. When they meet, they typically just argue. And And so here they meet in order to learn something that is relevant to all of them. And there is a dialogue going on. And the dialogue is really, really crucial because it's not about me transferring knowledge, no. It's about recognizing local knowledge that could be relevant to me. As an ecologist or as a philosopher or both. And what was very, very helpful for us and frightening is a paper we read after a year by Miriam saying, look, dialogue could be a problem. The deliberation process can bring people to, you can lose information because people will tend to agree. Imagine this charismatic lecturer standing there. People will want to agree with him, and then you will lose valuable information. So what is crucial for us is to say, no, we're not reaching consensus. We're not reaching agreement. This is about the type of knowledge that everyone can bring in. And it's about activism. We were told that no one would come, that people hardworking and poor people would not come at the evening to hear talks. This just won't happen. And the only reason they come, and I'm telling you, it's hundreds of people, the only reason they come is because they have something to give, and everyone wants to give something. If you have something to give, it means you have something. And they want to change something. And what they want to change, even if it's their own village, it's relevant to everyone else in the region. Okay? And so this is going on from 2011 until today. And one example is this resampling we did in a stream, in a spring, next to a Bedouin village. And it used to be this very, very important stream. I'm going very quickly, but as technology got better and it became completely in a devastating condition, and the whole local history of the village is just going away. What we did is a course about this, and people from all over the region, 100 people came suddenly to learn from the local Bedouins. And where I live, that specific village has a horrible reputation, and people don't dare enter. And suddenly you have all these, if you want to learn, you have to go there because the best professors come to teach there. There was someone coming all the way from Tel Aviv to teach there, together with a local women expert, okay? And we did, I don't have time, we did this survey, and we found out a lot on the plants there. And now you have these georeferenced maps from 1880 to 2018. If you can see, you have the satellite of today put georeferenced as layers on the old maps. And there's amazingly interesting, that I don't have time to talk about, ecological surveys and analysis that you can do here. And these people just applied for a couple of millions from the Israeli government, which they probably will get because they have high quality data. And why is it important for ecologists? Because when you look at these maps, these land use maps that the ecologist must use, who built this were the British. And what they did is they had a single metadata for all the Middle East. And so when you look at the index for things like this or this, you have here descriptions of vineyards, of orchards, of all types of agriculture that is completely irrelevant to this place. And since all the maps later on are built on the first one, without local knowledge, what you're doing is an ongoing mistake. So what you will have is extremely precise maps. And you can quantify on a difference of, I don't know, half a meter, okay? Where exactly is everything? Where exactly is every point on this map? But it will be like my example before. You will have excellent precision, but inaccuracy, because your categories are wrong, okay? And this work that is ongoing, I still don't know the results yet, is of tremendous value. And so the argument is this. given the basic importance of diverse local knowledge to fix inaccurate replication, either in sampling, experimenting, analysis of the data, and I didn't talk about it, a conservation policy. Because when we want science-based conservation, and if our science is inaccurate, the kinds of policy that these people meet in Israel make them outlaws, often, if they want to pursue their traditional way of life. Okay? Not to mention epistemic injustice of not recognizing local knowledge. Miranda Fricker wrote this beautiful book about epistemic injustice, which is the most common injustice we have. It's a wrong done to someone based on his recognition as a knower. And these people are never recognized as knowers. They don't know anything. They have anecdotes. They have stories. They don't have knowledge. Okay? So, given that this sometimes is important, okay, if this is sometime important for some cases, okay, then even if outreach activity to such local knowledge only sometimes improves replication, you know what? Even if it rarely improves replication, it should always be attempted. Because of this, because of the basic type of improvement that it can give us. And that's it.
How general? Is this very specific to ecology, or do you think it applies generally?
When you think about that, so first of all, when we did the book, we invited people from physiologists, we invited doctors who work on epidemiology. It has the exact same problem of being accurate about a particular population or saying something very general about many. So the groups that came to the workshop and participated in writing this book were ecologists, physiologists, molecular biologists, immunologists, and farmers, not farmers, but those who do research on farming. So in the life sciences, I'm pretty sure this is a general problem. This clash between accuracy and generality, I think it's a general problem. Is it a general problem in physics or chemistry? I don't know, but I suspect it's less. Well, I don't know. And yeah.
This is just a question about clarification. So when you had the pictures where there were 3 maps or 2 maps, and the picture before that had a barren area, the one before that, yeah, the slide before that.
Nothing happens.
That's it. That was it. Okay. So I'm just not sure what it
shows.
Represented. It looks like in 1920 nothing was growing there.
Okay.
But that's
I was in a rush to finish on time. Okay, so this is a classical case. I think not only in Israel, but definitely in Israel. You know, one can see one's wrongs and injustice when it's close to you. So there's a saying in never mind, it's in Hebrew. So it's easy for me to see up close, and it's better for me to fight against wrongs that I see up close. I'm sure there are similar wrongs in other places, but it's not mine, so I care less. This is a phenomenon that happens all over. You have a traditional village that the whole center, the heart of the village is the local spring. Everyone meets there. It's barren because there are hundreds of people coming there every day. They pick water. They have gossip. They meet. They court. All the big decisions. This is the heart of the village. Okay? And this is before the establishment of Israel. After that, you become a small minority group, okay? And often what you want to do is to imitate the hegemonic group. Sometimes also the hegemonic group doesn't see you at all, okay? Which also happens. This kind of way of life slowly erodes. And what you have is a village. They suggest to the villagers, we'll build for you something much better, modern. And so they move. And then they get pipes home. They move further. And then the children, who are now 20 years old, don't know where the spring is. Not only that, they don't know their local history. I was born, and I still am a member of a kibbutz. I think my kibbutz was built when the Turks were ruling the country, okay? In the middle of World War I. And I think there's at least 10 PhDs on this small corner, an insignificant corner of the world where I lived, okay? There is not one paper, not one, on this village. And it's not just this village. I think of the towns, the townships next to where I live. Kiryat Shmona, Chatzor. It's very interesting, but not enough for historical research. There's none. There's none. And the knowledge that these people have of their lives, of where exactly the stream is and how it looks, is considered, it's not knowledge. They have stories. But what happens is that this little stream brings water to the Jordan River and to the Sea of Galilee. And in Israel, and that's what's working, in Israel, you have a unified system that brings water all the way down south, hundreds of kilometers. And so what happens here will affect people living 400 kilometers down south from this village. And this is the project that was done.
British map.
Okay, but so what we did here is that we mapped and we checked the quality of the water. We mapped the area, and we managed to put together a program for, how do you say it in English, to reestablish with millions of dollars to reestablish this and to improve the water. And also, the villagers themselves want not just to tell their story, but they also want their water to be clean. So now it's an inner struggle to move away illegal cattle that belongs to the villagers themselves, that is doing all the damage here. And with these maps, this is even better. So
you said the British maps put orchards and so on that didn't exist on the map?
Oh, no,
What exactly?
it's cool. What they have this, they are very organized, and they want a common standard. So there's the metadata, what describes the data, is the same all over the Middle East. And you can see signs that when you read on the map, it says orchards. And when you read on the map, that sign, it says, for instance, here, this is supposed to be patchy agriculture. Which is this one? See, this is patchy agriculture. This is, I don't know how to say it in English. It's a specific thing that just is not there. Not in the sense that it's not really there. It's a code name for something else, because the British were very committed to having standardizing their whole empire, right? So you map it the same way. But when this is georeferenced with dozens of maps, all connected to this one, okay? And the scientists want to build this very precise conservation policy built upon quantifying the types. This is the types of soil. You see, this is soil type. Now, you want exactly this soil type, where it goes like this, to be relevant, okay, to what actually is on the ground. And you can quantify it by meters, less than meters. but from the start, and you want to say that the type of agriculture that you had here affected the kind of species that can live here, because this village exists about 300 years. And you know as an ecologist that land use highly affects species distribution. And you're so happy because you have all this tremendous, amazing information. But in the beginning, your information holds an inaccuracy. And the only one who can flash it out is the locals. Now, how did the British build these maps? They didn't even come here. When they came, Charles Wilson, who was the first one, and the Germans and the British who came to Israel, or to Palestine at the time, they had religious motives. Now, Tuba has no religious significance. They were never here. What they did, and these maps are amazing, what they did, they used airplanes in this case, okay, and hearsay in this case, and they were very, very consistent and very, very precise, but inaccurate, okay? And a century later, all the high-tech ecologists are building on these maps. That's why you need local knowledge. Now, it's also very political. Look how the name of the river changes, okay? And this is the Sharia, and this is Wadi Tuba. It won't surprise you that today it's not called Wadi Tuba, it's called Wadi Tubin, okay? And look at this map. Tuba is not here, the village is not here. This is a satellite map, okay? Suddenly this is old Tuba, historic Tuba. It appears here. Now, if you want to make a political claim about land ownership, and it's done, you take this map and you say, look, they were never here. Well, what do you want? They were never here, okay? But if you understand the relevance of local knowledge, you understand the methodology of how the mapping is done, and you acknowledge local knowledge, then you can make a difference. You see, then your conservation policy will not only be precise, not only could be general, but it could also, no, it can't be both, but it could be precise and accurate, okay? And what we do is that we go with people to the specific places and ask them, so what did your father grow here? And what do you grow here? And all these ecologists are amazed with the type of information they get, but they would never have thought to come here. It is so difficult. And you all, you know, you're from this hegemonic group, you're Jewish, you'll come to these Bedouins. It's like, who am I to, until you don't come? And also, they're not scientists. They're not scientists. Why should their knowledge matter? Okay? And it's a lot of effort to come to these people. It's a lot of effort to come here. Why do it? Okay? So what I'm saying is this. It doesn't always help you. But because when it does help you, local knowledge can make a very basic difference in your model. It makes sense always to try. That's the argument. Most of the time it won't make a difference, but it's like you negate something. You try it just to show that it's not relevant. That's how we should treat local knowledge. Otherwise, we will remain with ourselves and we will talk with each other. But the people, and we will build these conservation policies and never understand why do these local ignorants don't do what they're supposed to do to keep their plants? And why do these ignorants time and time again vote against what we think is right? And there's this we and them talk. And all this kind of educating the ignorant only deepens the gap between the academia and society. And what I'm suggesting is always try.
This is a wonderfully interesting example. Here we have similar issues, largely in the north. And I think there's an awful lot of Canadian biologists, and government biologists especially, who've come in recent years to appreciate Inuit knowledge about the Arctic. Polar bear behavior, how the sea is changing as the ice cap melts, and all of that sort of stuff. Even, amazingly, there was a case just a few years ago, the Franklin expedition was the British expedition to find the Northwest Passage, and the ship was sunk 150 years ago. And people in Canada have been looking for it for a century and a half. Turns out the Inuit knew where it was all along. And they're passing it down the hallway. Somebody just asked, well, you'll find it over there. It was a remarkable case of verifiable local knowledge. There is a tension in another place, and it's a kind of political, it's not the same political problem as in Israel, but maybe there's some similarities. And as Indigenous peoples want increasing autonomy, and a lot of people are very sympathetic, including me, but sometimes it will amount to, well, what's to be taught? Who's going to have control over education? And so every sensible person is a Darwinian. Well, some of them are not, and they'll give you a very different cosmology. And this isn't small potatoes, in their sense of self. It's a big deal. And how to cope with that seems to me to be...
I have a good example. So I have example exactly for that.
Yeah.
Because this is just one course, okay? This is a project that came out from one course. We have like 10 like that a year. And one of the big problems we have is between the kibbutzim, which are left and more Ashkenazic Jews, and the people that live in towns, which are vote mostly to the right and are much more conservative, and Sephardic Jews. And again, they don't meet that much. And of course, in the academia, they would say, oh, these are all these kibbutzim and these liberals. And so when we asked people what do they want, we were invited to this neighborhood. Well, we invited ourselves. We asked, is it okay if we come? They said, yeah, sure. And we asked them, so what kind of course would you want to learn? And all the people who kind of know about social involvement told me, look, be modest. First of all, people won't come. And if they will, maybe 5, 6, and what they would want is something practical. These people don't have time for philosophy. What they want is something about day-to-day economy, day-to-day parenting. They need advice. And I think that's what they'll ask for, and see if you can find someone for that. And when I asked them, what do you want? The answer I got, so the first course we did was about modern physics. That's what they wanted. Modern physics. The second semester, we went and it was in this club of people with mental issues. Okay, and they could participate that way best. The second semester, we went to that neighborhood, highly conservative, mostly religious, and I asked them, so what do you want? And they said, you know what? We are very religious, and we call the time here how what we believe doesn't fit science. And we don't like that it doesn't fit science. So maybe we should have something we should learn about science. And I said, look, I don't know. The only thing I'm a philosopher of ecology and evolution. I can do that. I said, yeah, sure, evolution is great. That's what we want. Doesn't mean they'll agree with me. That's what they want. And what we did in the course, instead of me coming and teaching them evolution, as if there is one understanding of evolution, which is rubbish, what we did is that I brought along with me someone who disagrees with me. He's a scientist, like me. We teach, but he believes in evolution in a Dawkins kind of way, the selfish gene. And so we disagree on almost every model. And we taught together, and every time I said something about evolution, he would say, no, but that's not exactly, you can see it that way. And every time he would explain something, I would say, but you can see it that way. And the third guy was someone who was very religious and accept some aspects of evolution, not all. And the course was amazing because they had this freedom to feel like they can learn about it and nothing bad, first of all, nothing bad will happen because scientists themselves disagree. Second, it doesn't hurt their basic beliefs because one of their own participated as a teacher. And as it moved on, eventually they wanted also others to come to the course, their teenage kids. So it didn't move to a larger project like this, but what it showed me is that if you don't think that science is some kind of a monolithic thing that you should transfer to the ignorant, but it's something that can be learned together. And there's a lot of debate, and we don't have to be afraid of exposing the debates within science. Think about how much effort is invested in portraying this consensus view of climate change, of evolution, a lot of things. If we're not so worried about our fortress that we come to learn together with someone else, I don't know. And I can't say anything general, but at least in that neighborhood, it changed things. It changed the discourse. And evolution is not a problem. I don't know if it's a general thing, but I do think that we are often, not obsessed, but we are often very scared of meeting someone who has a very different set of beliefs than us. And I think that often when you start the dialogue, a lot of it dissolves. And some of it doesn't. Some of it doesn't. I don't think any one of them will start to vote to the party that I vote to. And a lot of the wrongs done in my country is people doing something good to someone in the hope that he will change his mind. Like we will educate them in the hope that then they will stop voting for someone. Trump, Netanyahu, whatever. And I think that's trickery. People can smell that a mile away. If you come to educate me, to change me, thank you very much. I'm okay. If you come to learn together with me and you think that I have something to give you, that interests me. So our main thing that we learned is that people come because they think they have something to give, not because they have something to get.
You skipped over something quickly that's rather important. What kind of crazy village thought that the thing they wanted most to learn about was modern physics?
So we did, what we did is this. We were told by everyone, it wasn't a village, it was in a town. We were told by everyone that what they want is practical stuff. But it turned out that everyone thought that way. And year after year, these underprivileged people in this neighborhood would get economical consultant year after year. Economical consultant and educational consultant. Every year they would invite them to hear about education and economy. And they had enough. They had enough. That's why. I think that's why. It wasn't about us. I think that's my guess. They picked the most weird, and it was an amazing course. And one of the things was that for a family that is a single mother raising 5 kids, okay, she doesn't have time. Why would she come? She doesn't have time. So we did, because the physics course was so great, we did it 3 years later again, but this time with a group for kids. So she could come with her kids, put them in to learn about physics. She would go to learn herself, and then they could talk about it at the evening. But it was also about ADHD, and it was also about gender, and it was also about ecology, whatever people care about. And it doesn't always work. Sorry for being so excited. You know, it's not like that. I aim high, but often I see where I fail. As you said, where replication fails, that's where you grow. And so we mostly fail in the sense that you want so much. Well, yeah, you get it. And I think you had enough, right? It was a long day. Thank you so much.
Yeah, let's